Good afternoon, everybody. I hope you guys are doing well. It is 3 p.m. for me, and I'm not gonna lie, I'm a little bit tired, just a little bit, but not enough to stop me from doing this this lesson. I was over the past couple weeks, I've been trying to get my fucking Bard's Tale video done, and oh boy, it's been worth it. I'll be late, early warning, that's fine, that's fine. I have no idea what a Lambda function is. We're starting with Lambda functions today. I don't know what that is. I don't know what it means. FreeCodeCamp, I learned C++ with that years ago too. Oh man. Well, it's good to know that I'm not the only one. I don't know how to do anything in C++ now. Oh no. That's not good. You're supposed to be like, oh yeah, I got a fulfilling career and everything is gravy, you know. Like, I got a great job that I love, you know. Oh no. But yeah, so I'm not gonna lie, I don't know what a Lambda function is, period, like at all. The first time I ever heard it, I was like, wow. So we're playing Half-Life? Is that the kind of Lambda function we're working with? But I'm going to go out on a limb and say that's a no. Hey, I'm saying hi, but I gotta put music on because I need to concentrate on drawing anatomy for manga today. Hell yeah, dude. Hell yeah. No, I got a part-time cleaning job. Oh man. I'll probably have to get something similar here in the next couple months or so, unless I really want this, unless I decide to go back into the government, man. I don't really want to do that. Anyways, we're gonna go ahead and do Lambda functions. Now, as mentioned before, this is and obviously in the title, this is the C++ programming course, beginner to advanced with FreeCodeCamp. The video so far has been phenomenal. Very good. Easy to follow, good instruction. There have been a few complaints that I've had here and there, but they've been the exception rather than the rule. So let's get ourselves squared away. I'm talking like I'm fucking Elmer Fudd or something, or Porky Pig. That's all, folks. All right, let's go though. So, as before, this is Daniel Gakwaya with FreeCodeCamp. Very informative video. We're over the halfway mark on it now. We're over the halfway. I'm kind of excited about that. We are technically, after this one, will only be 5 chapters from completing the video. It is going to be because this is chapter 14. Yeah, so like we're currently we have 6 chapters remaining since we're at the beginning of this one. Because there's 19 chapters if memory serves. That said, these later chapters, like this one, inheritance is like 4 hours long. Polymorphism is like 4.5 hours, 5.5 hours, or 4.5. No, it's 4.5. It's gonna. So some of the later chapters are gonna be pretty long, but this one, the goal is to complete Lambda functions today. All right. So let's do it. Take it away, Gakwaya Sensei.
I would like to welcome you in this new chapter where we're going to be learning about Lambda functions. Lambda functions are a mechanism we have in C++ to set up anonymous functions. Once we have anonymous functions set up, we can do all kinds of crazy things with them. For example, we can give them names and call them multiple times, or we can even call them directly without even giving them a name. I realize this can be
How do
really
you do
cryptic,
that?
so
That
we're going to
sounds
head over
insane.
to the next lecture and see how we can declare and use our Lambda functions. Go ahead and finish up here and meet me there. In this lecture, we're going to
Wait. So is a Lambda function just a function that doesn't have a name? That sounds fucking insane. Why on earth? First off, why on earth would you want to do that? Which we'll get into the lesson probably, but we'll see. Why on earth would you want to do that? And and the one that we're definitely going to get an answer to. How does that work? That's super. Well, frankly, weird. Like I don't. Everything has had a name so far. Like this this function called int main has a name. I don't know how you would make a function without a name. Well, let's see.
see how we can declare and use our Lambda functions. And again, Lambda functions are a mechanism we have in C++ to set up anonymous functions. And an anonymous function is a function without a name. We're going to see how we can set up an anonymous function, optionally give it a name and call it, or we can even call it directly without giving that a name. Let's see how we can do that. Before we talk about anything about Lambda functions, we're going to first see the Lambda function signature.
Okay.
And there is a special syntax you have to follow if you want to set up a Lambda function in C++. The first thing you have to put in place is angle brackets like this, and that's going to be your capture list. We are not going to talk any more about this. We're going to have a chance to talk about this in detail. After your capture list, which is going to live in this pair of angle brackets, you're going to have the parameters to your Lambda functions. And this is where you can pass arguments if you want to call your Lambda function.
Okay.
After that, you're going to have a return type for your Lambda function, but you don't
So you
have
put the
to
return
put this
type
in
after.
explicitly. You can leave this out and the compiler is going to deduce your return type by itself.
Oh.
After all these things, you have to put in a pair of curly braces, and inside these curly braces, we're going to have our function body, and we can do whatever we want our Lambda function to do in this function body here. After this, you will have to remember to put your semicolon to make whatever statements contain this lambda function to be valid. And this is the syntax you have to follow. Here we have a simple example. So we have our lambda function. We want to say hello to the console. This is what we have in the body of the lambda function. But notice that we have our
What the
capture
fuck?
list, which is going to be
It's empty.
delimited by these angle brackets. We have our parameter list, which is going to be empty in this moment because this lambda function doesn't take any parameter. And we have our body, which is going to live within these two curly braces. And after that, we have our semicolon to make this a valid C++ statement. If we try and put this thing in our C++ source code, this is going to be a valid lambda function. But it isn't really useful by now because we can't call it. One way we have to call it is to give it a name. And we can give it a name by assigning our lambda function to a variable like we see here. Once we have our lambda function declared like this entire thing is going to be our lambda function type. We can take this and assign that to a variable which is going to deduce the type using auto type deduction here. This is what we are doing. Once this thing has a name, then we can call it with the syntax we have here.
Okay.
And if we run this code now, it is going to print hello world to the console.
So the way that he's explained this to me makes it seem like, I mean, well, when we use auto and we give it a name, it seems like it's kind of like, well, why would I bother doing this if I'm going to just give it a name anyways? That's kind of my main question with it so far. And then, I mean,
I realize this syntax can be really cryptic, but
it is cryptic, absolutely.
This, you're going to find that lambda functions are really cool, and later in the course we will see that they really make a lot of things easier in C++. So try to remember the syntax here, and
they make things easier, huh?
Flow from here. Again, the syntax is to have the capture list, which is going to be the first thing. The second thing is going to be the parameters. The third thing is going to be the return type, which is optional. You can leave this out and the compiler is going to deduce this. And after this, you're going to have your pair of curly braces, and the body of our lambda function is going to live within these curly braces. This is the syntax you need to remember. Okay, we have seen that we can give a name to our lambda function and call it, but it is also possible to call our lambda function directly without giving it a name. And we do that by appending a pair of curly braces to the lambda function definition here. So we have a lambda function, we have our curly braces in, we have our parameter list, we have our body here, and after the closing curly brace, we're going to add a pair of parentheses to call this lambda function. And because this lambda function takes no parameter, we're not going to put any argument within our parentheses here, and this is going to call our lambda function. Don't worry if you find this confusing. We're going to head over to Visual Studio Code in a minute, and all of this is going to make sense.
I'm going to need that.
We haven't really seen that we can pass parameters to our lambda function. Here is a simple example that takes parameters. This is a lambda function because it follows the syntax for lambda functions.
You put the things in here.
Our capture list, we have our parameter list, we have our curly braces, and the body is going to live inside these guys.
It's just a basic addition.
This lambda function directly with this parameter list. The lambda function is going to take two parameters of double type. We're going to print out the sum of these two numbers, and we are going to call this lambda function directly. Notice that we are passing in our arguments as double literals. Okay, this is how you can set up a lambda function that takes parameters.
So why I want to learn C++? Main reason is because I would like to do game dev. And I've talked about it for years and never taken any action. And so this is my action. This is me doing something about that.
The lambda function is now going to return something, and this entire thing we have here is going to be a lambda.
I messed a little bit with Unreal 5 once upon a time.
It is going to return something, And what the
but
lambda function returns is going to be
I didn't
assigned to this
keep up
result
with it
variable here.
because I
And
didn't
if we
have
print it, we're going to get the
anybody
sum
or any
of
way
whatever
to
pass in here printed out on
maintain
the console, and we're going to see
integrity
it
on it.
printed out on the terminal.
So I'm
It is
hoping to
also
do this
possible
and
to
then
put
go
your
back
lambda
to that,
function directly in
and
an output statement.
with
I
hopefully
realize
a
this
better
can be really
understanding of what I'm
confusing,
doing,
but please look at this entire lambda function thing here
but with
as a
doing it while
single value,
streaming makes
because
it
this
so
is a
that
lambda
I have a
function that is
thing
going to return
that I am
something,
doing
and what
for
is
stream.
returned by this
Makes it
lambda
easier for
function
me
is going
to
to be
force
printed
myself to do
as
it.
our result here. Again, I realize this may be confusing to many of you guys. We are going to head over to Visual Studio Code in a minute, and we're
I
going
mean,
to
this
see
kind of makes
this,
sense,
and you're going
right?
to really understand.
I mean, all he's done, right, is he's passed his he's I don't quite understand how this works in the compiler, but I understand that it does, right? Because like we've created an anonymous function here that when when called, at least in his version, right? Let me get my mouse over here. Let me there. So when called, the function will print this stuff, and there's this, and then this function has it's like this is the capture list. These are the parameters which we've passed as doubles, and then the return is a plus b, and then these are the arguments for what a and b are, as stated in here. So it's very like it makes sense. It looks fucking strange, and is nothing like what we've been covering, or not nothing, but it's it looks way different from normal functions that we've made. But it does kind of make sense when I look at it.
Okay, the last thing we're going to look at is that we can specify a return type to our lambda function. And the syntax to do this is to do a dash, a greater than symbol, and put your type after that. And when you do that, now this lambda function is going to be forced to return double type. Even if you pass it to parameters that are not of double type, we are going to add them up, and the return type is going to be implicitly converted to double, and that's what we're going to return, and we can print it out on the console. And we're going to see an example of this in a minute when we hit Visual Studio Code. In fact, this is really all I had to share with you in the slides. I realize many of these things may be confusing. We are going to head over to Visual Studio Code and play with these things step by step, and I am sure you're going to understand. Here we are in our working directory. The current project is declaring and using Lambda functions. We're going to grab our template files and put them in place. Let's do that. And we're going to grab our folder here and drag and drop it in Visual Studio Code, and this is going to open it. It is opened here. We have our main CPP file opened. We can close the left pane here because we don't
Yeah, he's
want
just gonna
it
clean this
anymore.
up. Let me
And we
open up
can
my
clean up
terminal
our function
actually,
here. And the first thing we're going
because
to do
I
is
didn't do
to
that.
put in the syntax for a Lambda function here and use it as a reference as we learn about this. I think this is going to make...
Yeah, you know what? That seems like a good idea. That seems like a good idea, because I I am far from comfortable with any of this shit. I actually like my... Ah, god damn it. Okay, there we go. So we can do like that. Lambda function signature. And here we'll just do... This one says capture list parameters. And then this one, return type. And then function body. Alright, so we do it like this. Okay, so we're gonna do one more down. So essentially what we're doing here, right, our capture list, I think we'd call this undefined. I'm not 100% on that. Parameters are also undefined. Return type is not specifically defined. So then here, when we do this, I'm kind of curious. This should run, right? Terminal run task. And like this is maybe me getting a little bit ahead of myself. I'm sure he'll do this as well, but I'm curious. I'm curious now and I want to see. It just prints, dude. That's fucking weird. That is I have no idea. Like, can you imagine receiving instructions that look like this and understanding what the fuck you're supposed to do? Pointers are what I had the most trouble grasping. I can understand why it would be confusing. I don't recall having too many issues with it myself. It was kind of weird to do like I almost thought of it like negatives in a way, like like if you wanted to modify the value, you had to specifically, like, you had to dereference the pointer by almost doing like what in my mind was a lot like a double negative, right? But that, like, I mostly wasn't sure why we would do pointers. Like I kind of understood it eventually, but it seemed like at the time it seemed kind of like extra work, extra things to remember and think about when we're working with things.
things a little easier. So the first thing we want to do is to declare a Lambda function. And the
All right.
first thing we need to put in is a capture list. A capture list is going to be englobed in these angle brackets. So this is our
I'm
empty
curious
capture
what
list.
a capture
And after
list
this,
looks
we're going to
like
put
one
in
that
a
actually has
parameter
stuff.
list, which is going to live inside these parentheses here. After that, we're going to put in an optional return type. For now, we're going to ignore this. And after that, we're going to put in our pair of curly braces. And inside this pair of curly braces is where the body of our Lambda function is going to live. So inside here, we can do whatever we want in the body of this Lambda function. For example, we can say hello world, which is the logical thing to do at this point. So we're going to say hello world here, and we're going to put in our new line character with ENDL. Okay, now we have a Lambda
Yeah,
function
we did this a little bit.
declared, but we have to put in a closing semicolon because this is a C++ statement. Okay,
Yeah,
now we have
and it
our
didn't affect
Lambda
this at all
function
because we just
declared, and this
passed
is valid
nothing.
C++ code. If we
But
try to
technically,
compile this
that's not
program, you're going
necessary.
to see that it is going to compile fine. Okay, build finished successfully. And if we try to run it, it is not going to do a thing because we are declaring the Lambda function here, but we're not calling it to get it to do things.
Oh,
So
well, yeah, I
let's
guess
bring
that's
up
what
the
this would
terminal and
be,
show you that if we run
because
this
this
program, it is not going
attempts
to do
to
anything.
pass
So
an
let's
argument to
do
it.
clear and run rooster. You're going to see that it's not going to print anything. And we can even go down here and put in a closing stdc out statement saying done to mean that we are hitting the end of the function here without
Yeah,
doing
that way
anything.
you know it's not
So
crashing
if
at
we
least.
build again, the build is going to be good. We can clear and we're going to run rooster. You see, we are printing done. We are hitting the end of the function here, and we're not seeing hello world. So this function here, or this Lambda function here to be exact, is not being called. One way we have to call it is to give it a name. And we have seen that to give it a name, we have to assign the entire Lambda function thing we have here to a variable. And we're going to use autotype deduction here. So we're going to say autofunc, and we're going to assign
Let's make our stuff
our
look like
Lambda
it is.
function here
Autofunc.
to this variable. And this is going to be basically a handle we have in our program here to the Lambda function.
Okay.
And we can use this handle to do things with the Lambda function. But by now, I want you to see that even if we run the program now, it is not going to do anything because we're still not calling the Lambda function here. Let's show you that we're going to build again, and the build is going to be
Are you going to show me to do this?
And run rooster. Still no hello world because we're not calling our Lambda function. To call our Lambda function, we have to use our handle here, which is this variable, and use regular function called syntax. So we can go down here and say func, and we can put in our parentheses. We're not putting in any parameter because this Lambda here doesn't take any parameters. And now, if we run this program, it is going to say hello world because this line here is going to call this Lambda function. Let's build and see that. we're going to use
Okay.
GCC to build.
This
So
this
now,
makes
if we
sense.
clear and run rooster,
Calling the
we're going
function
to see
this way
hello
makes
world.
perfect
We can
sense.
call this function multiple times
Because
because we
we've
have an
given it a
handle to it.
name.
The handle is
The
going to be
syntax
valid
here is
throughout
weird to
the
me.
scope of the main function here. So we're going to go down and call it again. And if we build, we're going to build with GCC. The build is good. We can clear and run rooster. We're going to say hello world twice because we are calling our Lambda function twice. This is one way we have to call our Lambda function.
Makes perfect sense.
So we're going to comment this out because we're going to see a few other things. And on top here, what we were doing is declaring a Lambda function and call it through a name. Now we're going to go down, set up a Lambda function and call it directly without giving it a name, because that's also a possibility in C++. For that, we're going to grab our Lambda function here and we're going to copy it. And we're going to say declare a Lambda function and call it direct. And the syntax to do that is really simple. You set up your Lambda function like we have seen before. You see, this is our Lambda function statement here. But you're going to go to the closing curly brace and add a pair of parentheses.
Yeah, and that's what we saw. That's what we did before.
And call it directly. Notice that we don't have a handle to this Lambda function. So if you do things like this, you will have only one chance to call the Lambda function. So we're going to say
it's only going to call it once, but could you call it again a second time, maybe a third or fourth time?
After that, we're going to say because we're going to be hitting the end of the main function here. Let's build the program and show you that. We're going to build with GCC like we always do. We're going to clear and run rooster. This is going to say hello world.
Yep.
And we're going to be done here because we are calling this Lambda function once. Again, notice that now we
if I do it like if I do another one, function, so that doesn't call it twice, does it?
Wait,
is that oh wait, yes it is. Okay. Never mind.
Call directly, and you don't care about calling it ever again in your C++ application. And we're going to see that we have many kinds of problems where we want to do these kinds of things. Okay,
really?
now that you have said this, the next thing I want
are there that many times when you would want to create a function, a specific function that you just never want to call again? That feels like a really, really niche kind of thing, because why are you creating a function then? Or is it one of those things where, like, you make a Lambda function until you realize you need it a second time, and then you're like, oh, yeah, let's actually name this one? Let's make this a normal function and not an anonymous one? Maybe, but that, like, I don't... Why though? Why though? I don't get it. That's kind of... It seems really funny to me. It's like, oh, shit. Guys, does anybody know where that function is in the code? I know we've written like 3,000 lines of code like just in the past few hours, but like, does anybody know where this one particular function is? It's not named, but we need it again, and I know we already done it. Like, come on.
To show you is how to set up a Lambda function that takes parameters. And we're going to comment out what we have on top here because we don't want noise output on our terminal. And we're going to grab this Lambda function.
Modern C++ has a lot of cases where you only need to call a function once. Really? That sounds...
And we want to pass two parameters.
That just sounds like so counterintuitive to me. Because I'm like, I've been under the impression that creating functions is almost exclusively something that we... Not almost exclusively, but it's like, the main purpose of it is like to minimize the amount of like new code that you have to write. You know, like, okay, I have a function for this, I have a function for that, I have a function for this other thing, you know, and you can use them in different ways, like you almost like a build your own tool set type situation. Usually it's better to just use a real function if you use it once. Lambdas are primarily for passing functions as arguments or to capture certain variables. Huh. So you're passing you're passing a function as an argument in a larger function? That's interesting. That's I mean, that sounds like some shit that you see in like Minecraft Redstone video type shit. It's like we use this larger thing, and then we created an even larger thing to encapsulate it, and then we created a really simple thing that requires both of these larger things to be to function. All right, let's see. So this is the Lambda function that takes parameters. Lambda function that takes parameters. Boom.
Let's copy it. We're going to go down here and put it in. And we want to pass two parameters now. Let's pass in double parameters. We're going to pass in double A and double B. We can do that. And inside the Lambda function, we can print the sum of these two variables. So we're going to say A plus B, for example, and we're going to print out whatever is the result of A plus B. Let's do that. And after we do that, you're going to see that we get a compiler error because now our Lambda function is taking parameters, but we are calling that with an empty list of parameters. So we need to give it something to sum up. Let's give it
cannot be called with the given
example,
argument list.
and
That makes sense.
and see what we get. And after this,
10.0
we need to put in our semicolon because this is a C++ statement, and any C++ statement needs to end with a semicolon. Now, try to think about what we are doing here. We are setting up a Lambda function. Okay, it's going to end at this closing curly brace. And this Lambda function is going to take two parameters of double type. And inside the Lambda function, we are going to print out whatever is the sum of these two parameters that we are taking in here. After that, we are calling our Lambda function with
so it should just print A plus B
and 5.0. Or I should say two double literals. That's what we are calling our Lambda function with. And now, if the program runs, the Lambda function is going to be called once, and we're going to print out whatever is the sum of these two numbers, and that's going to be 15. Let's build. So we're going to build with GCC. The build is good. We can clear and run rooster. We're going to see A plus B is 15. We are calling our Lambda function here. If we put in 50 here, for example, we're going to get 60 printed out because that's going to be our sum. Okay, let's build again and see that printed out. If we run rooster, we're going to see 60 because that's the sum of 10 and 50 here. Another thing we
makes perfect sense so far.
Not to call the Lambda function directly here. We can actually comment this out. I don't want to take this out because you might want to use this as a reference. So we're going to
that's what I've been doing with most of the code.
Set up another example that is going to name our Lambda function, and then we will have a handle to the Lambda function, and we can call it multiple times. So let's take out the call we are doing here, and we're going to assign our Lambda function to a variable. We're going to say auto func1. We can call this func1, no problem. And now we can call this Lambda function multiple times. For example, we can say func1 and pass in 10 and 20. Okay, and we can say func1 and pass in 5 and 7. Why not? If we run this program, it is going to print the sum of 10 and 20, and it is going to print the sum of 5 and 7. And it is going to be calling this Lambda function multiple times. Hopefully you can see that if you want a chance to call your Lambda function multiple times, you will need to give it a handle like we are doing here. And then you can use that handle multiple times and call your Lambda function however many times you want. So let's build this program and see what we get on the console. We're going to clear and run rooster. Now we're going to see A plus B is 30. As a result of this call here. And
all right, let me run this real quick. Run task. And then we run this. And it should just print the two values, 30 and 13 or whatever. 12. Yeah. I can do math in my head, guys. I'm super smart. I'm fucking wicked smart. You know what I'm saying? Yeah. So we pass the function multiple times, and then it prints out A plus B, with those being our parameters, and then it gives us the actual thing, or what our result is. Okay, but then again, this again feels to me like we've created a normal function, essentially. Is this still... It is still considered a lambda, by the looks of it. Class lambda. double A, double B, void. I wonder if the... Oh, void is like the return type. It looks like. I think that's what this is, what this means. Interesting. All right, let's continue.
And we're going to see a plus b is 12 as a result of this call here. Notice that we are passing an integer literals. So the compiler is going to insert an implicit conversion from
Fun fact,
int to
lambdas are
double
just classes that are
because
created
our lambda
implicitly.
function here is
The
taking
lambda's
double
functionality is the
we really need to
class's
be aware of these implicit
parentheses
conversions
operator being
and make
overloaded.
sure they are working to
Really?
our advantage. If they are working
So this is the
against
first
you,
time
try
I'm
to find
seeing
a way to
anything
make
that's
your code
called a class.
work
That would be a
exactly
class?
like you want. Because we are learning about all these cool tricks in C++, you're going to be using them at your advantage. Okay, hopefully
That is the
now
hope.
you know how you can set up a lambda function that takes parameters.
Yes.
We're going to go down and comment this out because now we want to see how we can return something from a lambda function. And we're going to be using the same lambda function here. So let's grab it. And we're going to say lambda function that returns something. And we're going to set up our lambda function here. Let's put that in place correctly. And instead of printing out the sum of a and b, we can return that. We can go in our lambda function and say return a plus b. Okay, now that we have this, we can either call it directly by saying, for example, 10 and 20. But now, if we try and run this code, it is not going to do anything. Try to guess why.
Ooh, okay. Let me get it printed out. Let me get it written, and then I'll read through it and see if I can guess why. That sounds like a fun exercise. All right, let's see. So we have our thing. Let's just make our thing look like his thing. So we have our lambda function that returns something. Okay. This. Oh wait, no, that's me fucking up. Okay. Double A, double B, return A plus B. So logically, to me anyways, this looks like it should just return whatever the addition. I mean, I guess this is a function as well. It should just return 30 here, right? I guess because we haven't actually told it to print anything, maybe? That's my guess. Because we haven't told it to send anything to the console. So it'll just go to done. It'll return this value, but I don't know if return automatically prints to the console. I don't think it does. I would assume it doesn't. All right. Let me know, Gakwaya. What's wrong? Why won't it work the way we think it will?
This lambda function is not printing to the console directly. It is just returning whatever is the sum of 10 and 20.
Fucking big brain over here.
We're not doing anything with whatever is returned from this lambda function, so we're not going to print anything, and we're just going to print down here. Let's work and make you see this, because you really need to be aware of these little things. So
I mean, it's like a detail that's really important, right?
We're going to see
down.
Oh,
whoops, that's the wrong thing.
Is returning something, but we're not doing anything with the return value. If we want to print the return value, we need to catch it somehow. And we can put that in a variable, for example. We can say auto result and assign the return value of our lambda function to this variable. Now we have a chance to print this.
Okay. So auto result. Again, we're letting the compiler decide what we're returning. I almost wonder if, like, because we passed this as we pass these arguments as integers, I wonder if even though these are considered doubles, if it'll just return an integer. I'd be kind of curious to see that. Maybe. Yeah, let's see.
For example, by doing stdc out result, and we're going to print that out and say result. Now if we build this program, it is going to print whatever is the sum of 10 and 20. Let's do that and show you that this is actually the case. So build is good, so we can clear and run rooster. Result is 30. If we pass in 10 and 50, for
Look
example,
at that.
we're going to get the same thing. Let's pass in 60 here. So we're going to build with GCC. The build is good. We can clear pretty quick and run rooster. Now the sum is 70, and this is how you can return stuff from your Lambda function. And once you return stuff, you have to be sure you catch your results and print them out. Another thing you can do is print out the result directly after you call your Lambda function. So for example, we can grab this entire Lambda function thing here and put that in an stdc out statement. So we're going to put in a second one here and say result, or we can even comment this out. We don't want to be confused when we look at the terminal here. We're going to comment out the first stdc out statement here, and we're going to say stdendl here and put in a placeholder for our Lambda function, and we're going to paste it in. If we do something like this, again, this entire Lambda function thing is going to return the sum, and that's what we're going to print.
Oh, wait, hold on. We didn't want to pull this as well. So this should print it to the console. Oh, I don't want to do that. There we go. Let's get a few extra lines. This looks hideous, though. I hate the way this formatted itself. I mean, it seems like kind of inevitable because we put. I almost wonder, would it have been better if I'd done this? No, we're just gonna let it. We're just gonna let it ride. Let it look the way that it does. Let it be ugly.
I realize this syntax is really cryptic, but it is going to work. Let's try and build our program here. The build is good, so we can clear and run rooster. We're going to see that result is 70, and this is coming from our call here,
I mean, it works.
Which
That
is nested
makes sense.
inside our stdc out statement. You can do this if you want. Another thing you can do, as we have seen before, is give your Lambda function a name and call it repeatedly. So for example, we can try and comment out what we have here and set up another Lambda function because we don't want to confuse you again. So we're going to grab our Lambda function here. We're going to copy it because we don't want to type this 1,000 times. And we don't want to call this Lambda function directly. Instead, we want to give it a name, and we're going to say auto func2, and we're going to assign our Lambda function type to func1. Now that we have this, we can say auto result1, for example, and we can say func, and we can pass in whatever we want. Let's put in 23 and a 7, and this is going to add up 23 and 7. We're going to grab the result.
Okay, hold on. We got result 1 equals func1, but with 23 and 7. So, oh my god, I need to type properly. We created a func1. This we do like so. Yeah. Okay. So this looks like it's correct. Again, this portion of it where we're using auto kind of feels like we're just making a normal function, but with a what was the term? What was it? A capture list instead of instead of just like creating a function directly. I mean, this is certainly neat, but I'm curious as to why we would choose to. I'm always gonna say that. It's like, oh, I'm curious why we choose to do this over another. I feel like I'd need to see probably a fairly low level example of either of any of it to start making heads or tails of why we do certain things. I'm hoping that I'll get some enlightenment by the end with a lot of these things.
And we're going to assign that to result1. If we go down and say auto, for example, result2, and say, for example, func1, and say 9 and 45, why not? And go down and print out these result variables. We're going to see the sums printed out. And again, the message is that we can use this handle to call our Lambda function multiple times. So let's go down and print these out. We're going to say result1, and we're going to say result1 here. We're going to go down and say result2, and we're going to print that out. And we can even call this Lambda function directly and put that in stdc out here. So let's say that we're going to say result3, for example, or direct call. I think this is descriptive enough. So we're going to say func1, the name of our Lambda function, or the handle to the Lambda function, and we can put in a 5 and a 2, for example, and we're going to see this print out the result. If we build our program, let's do that with GCC. The build is going to be good. We can clear and run Rooster.
Okay, we'll do the... I fell way behind there when typing all this shit out. Direct call. And this is func1, 5, 2, std, stdl. Alright. So, I mean, it should just be... this is just a basic addition, so it should just be, what, 30, 54, and 7, all printed to the console, and then done, of course.
We're going to have result1 is 30, which is 23 and 7, so the sum is 30. The second one should say 54 because that's the sum, and the third one should say 7 because that's the sum of 5 and 2, and it is what we have here. And after that, we're going to see that our program is done. This is how you can set up a Lambda function that returns something, and we have seen many ways we can work with this. Let's comment this out because there is one more thing I want you to see, and that's a Lambda function whose return type is specified explicitly. Okay, we are going to reuse the same Lambda function we have been using all along, and we're going to copy that, and we're going to go down and put it down here. And now we want to specify the return type as double. The way we do that, we go after our parameter list and we put in a dash symbol and we put in a greater than symbol, and then we're going to specify the return type of our Lambda function. Let's say that we want our return type to be int. This is how we say it. Now our function here is going to return int regardless of the types that we put in. So what the compiler is going to do when we call this Lambda function, it is going to take the parameters, it is going to add them up. For example, now they are double, so it's going to add A and B as double. It's going to produce a double variable. Then it is going to convert that to int and return it. You notice that now we have forced our Lambda function to really return a specific type here. Before, the return type was deduced from the operation that we did here. And before we were returning double because that's what the compiler was deducing for A and B here. To really drive the point home, let's assign this Lambda function to func1 or func3.
I just noticed that all of my text is blue. Why the fuck is all my text blue? That's really weird. Interesting. So as soon as I define a type, all the subsequent text turns blue. I hope that's not a problem.
Let's do that. We're going to say func3, and this is a Lambda function that is going to explicitly return int. And we're going to set up another one which is going to deduce the return type. We're not going to specify the return type explicitly. So we're going to take out our return type here. Let's do that. And we're going to go down and say auto result3, and we're going to say func3 and add up two double variables. Let's set up these variables explicitly so that you really see what is happening. So we're going to say int a and put in a 6.9, why not? And let's make this guy a double because that's what our function here expects. And we're going to do another one, do double b, and we're going to put in a 3.5, for example. And we are going to use this variables as arguments here. We're going to say A and B, and we're going to say auto result for, this should be func4, sorry for this. And we're going to say result 4, and this should say result. I am making many typos. So we're going
Dude,
to
tell me
assign
about it. I
our
have been
lambda
fucking up my
function,
text
the
all day.
result of our lambda function, I should say, to result 4 here. And we're going to pass in A and B.
Dude,
Now,
why the
we
fuck
want to
can't
see
I type the
types
fucking
of result
button?
3 and result 4 here. We're going to go down and print them out. We're going to say stdc out size of. This is one way we have to get the.
Oh, I just noticed that he called this one func4. And all of my text is still blue. That implies to me that something weird is going on. It seems like it's fixed for down here, but why is this white? This one blue. It's stressing me out a little bit, I'm not gonna lie.
The types of our variables. We're going to pass in result 3. We're going to say size of result 3. And we're going to go down and say size of result 4. Okay, we have our code in place. And what we want to see is the type that is deduced by the func3 lambda function here. We are explicitly turning the return type int. The parameters we pass in are going to be double. That's what we have here. We are going to add up A and B, and the result of this is also going to be double. But the compiler is going to notice that we are returning int explicitly here, and it is going to take this double result and transform that to int.
Yeah, it should truncate it.
And we're going to get the result of that assigned to func3 here. For the second lambda function here, we are going to automatically deduce the return type. So what we return here is going to be a double type. And we should see a size of int for result 3 here printed out. So we should see a 4 on my system. And for the second statement here, we should see a size of double printed out. This is one way we have to try and prove this. So let's build this program and see what we get. Okay, the build is good. We can clear and run rooster. And we're going to see that this is exactly what we expect here. If we want, we can even print result 3 and result 4 and see what we get. So let's do that. We are learning. So let's experiment with this a little bit.
Okay, so this actually gives me an opportunity to test something that I was curious about. So here we have it's automatically deducing, right? And we've given it we're feeding it 2 double values. But I wonder if when we do this, if we just make it 6 and 3, does that make it change to int? Because it's like, because it sees how, presumably because we'd be feeding it ints. It does not. Okay. So we know that if we tell it to feed doubles, it'll default to using doubles, which makes sense, and that's probably a good thing. But I was curious whether that was a thing that the compiler would change to.
We're going to say result 3, and we should go back and say result 3, if I can type ENDL here. And we're going to go down and say stdc out result 4. Okay, if we build and run this, we're going to see the results printed down. The build is good, we can clear and run rooster. Now we have result is 10 for the first thing here, for the first lambda function. And for the second one, result is 10.4. You can see that for the first one, the result was transformed from double to int. And for the second one, we deduced double. So we still have our decimal point here. Hopefully this makes sense. And this is really all we set out to do in this lecture, showing you different ways you can set up your Lambda functions. We saw the syntax of setting up a Lambda function. We saw that you can declare a Lambda function and call it through a name like func here. We went down and saw that you can declare a Lambda function and call it directly through the syntax you see here. We saw that how we could specify parameters to our Lambda function. This is the syntax. And once you do this, you have to remember to call your Lambda functions with parameters like we see here. We can even use a handle given to our Lambda function and call our Lambda function multiple times. After that, we saw that we could return something from a Lambda function, and we had many chances to play with us. And we finished by looking how we could specify the return type explicitly, and the syntax to do that is what you see here.
Yeah.
We are going to stop here in this lecture. In the next one, we're going to see how we can use our capture lists here and make them do useful things. Go ahead and finish up here and meet me there.
All right, give me 1 second. I'm going to open another folder. That way we can have a fresh one to work with when we start working with capture lists.
In this lecture, we're going to see how we can use capture lists in our Lambda functions and do some useful things.
All right.
We have seen that the syntax of our Lambda functions includes these angle brackets here, but we haven't really used them to do anything.
No, we
what
haven't.
we have done in the last lecture, they were empty all the time. In this lecture, we're going to use them. Here is a simple example of how we can use our capture list. We have two variables, a and b. They are of double type and they contain these values 10 and 20. But sometimes we want to use things outside the scope of the Lambda function inside the Lambda function here. And if you set up your Lambda function with an empty capture list, suppose you don't have these two guys in, and you try to use a and b like this, you're going to get a compiler error because the body of the Lambda function doesn't have access to the outer context here. It can only use things inside the Lambda functions or things that you pass to the Lambda function here, but it can't directly access things outside the Lambda functions. And we can have access to things that are declared and defined outside the Lambda function through our capture list. If you look here, we are saying a and b, and this is the syntax we have to capture these two variables, a and b, and have access to them inside our Lambda function here. And this is what capture lists are really for, giving you access to things that are declared outside the scope of the Lambda function. Because if you really think about it, this Lambda function thing we have here is really a type. So it is its own thing that has these behaviors built in so that we can call it and do things, but it doesn't really have direct access to the outside where it was declared. And you have to give it access through the capture mechanism here. Okay,
that
now
makes
that
makes sense.
I
understand why it's a capture value or a capture.
One thing we can do is capture by value. And if we capture by value, what we're going to have inside the Lambda function is going to be a copy. Suppose we have a variable here, which is c. The value is going to be 42, as you see here. We're going to set up a Lambda function and capture our c variable by value in this Lambda function here. And what we're going to do outside the Lambda function, notice the Lambda function has a handle, so we can call it. We're going to loop 5 times. And at each iteration, we're going to call our Lambda function and print the inner value here. But after that, we're going to increment our c variable, and this is going to increment the outer variable here. And what we want to see is that the changes we are doing on the outside here are picked up by the inner value that we have in our Lambda function here. And I hate to break it to you, this is going to not be the case, because what we have inside the Lambda function is a copy of the outside variable here.
Yeah,
what
that
we're
makes
going to have is
so.
for the
Well, does that make sense? So we create an integer called c, then we create an auto function. It's a lambda function with a the capture list includes the c. We have no parameters and no specified output type. It prints inner value, and then it just prints the 42 again, and then ends the line, and then we print it on the outside, and we increment c. So yeah, no, this I'm fine with this. I understand this because if we're incrementing c on the inside of this function, we're not incrementing it on the outside. I don't know. I feel like we'd have to probably we'd have to pass this by a pointer or a reference, I think, if we wanted to increment this value. I think. Don't quote me on that. I'm like still learning.
The outer value to go from 42 all the way to 47, we're going to go 5 times, incrementing this little guy. But the thing
Yeah,
on the
you're only
inside is not
incrementing
going
this
to change
C.
because it is a copy. The incrementation here is affecting the outside variable here, but it is not affecting the copy we have inside our Lambda function. So for all these loops here, we're going to see 42 printed out. And we're going to see this in a minute when we hit Visual Studio Code. Let's say 42 correctly.
Did I completely have that backwards? Is it printing 42 on the inside every time? No, it's going to be printing 42 in both every time, right? Surely. Surely it would print both. Or print 42 for both. Because here it copies it, and then that's all it does. Right? Oh no. Wait. I'm suddenly not sure anymore. Int C42. Okay. The auto function equals, we have our capture list C. We're capturing C, which is 42. The inner value, we print 42, and then ends here. And then we create a for, I think it's range-based for loop. So for size t I, so that's our incrementer. As long as I is less than 5, increment. Then it'll do outer value C. But wait, the way this is written makes this look like it's a different thing from this, which it could be. Let's keep going. Let's get the explanation.
Excuse my typing here. Okay, so now you know that we can capture by value and you know what this really means. Another thing we can do is capture by reference. And the syntax to do that is to add
He always goes through everything that we look at in the
variable that we capture here. And if we do
in the
this
slides
and run the same
when
code
we do
run
the
in the last lecture,
practical
we're going to
stuff.
see now that the changes we do on the outside are going to be picked up by the inner side of our Lambda function because we are capturing by reference.
Yeah.
What we have inside our Lambda function here is a true reference to the outside variable here. And we're going to see that now the outside and the inside are going to be incrementing together, and we're going to have 43, 42, 44, and things like that printed out on the console. Okay, this is really all I have to share with you in this lecture, showing you how you can use your capture lists and or by reference. We're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is capture lists. We're going to grab our template files pretty quick and we're going to put them in place. We're going to put them in the current project. And we're going to open this guy in Visual Studio Code by dragging and dropping in place here. And we're going to open our main CPP file, clean it up a little bit, and close the left pane here. Right. What we want to do in here is learn a little more about capture lists. And we're going to put in a piece of code to play with just that. We have two variables, A and 10 here. And we have our Lambda function set up. And let's take out our capture lists so that you can see the compiler error we see if we try to use them as is here. So we have our two variables and we have a Lambda function set up here. And inside the Lambda function,
hello Lazy, how you doing?
Trying to access variables that have been declared on the outside of the Lambda function here. And by default, if we try to do this, we're going to get a compiler error because these two variables don't exist in the scope of the Lambda function here. Let's bring up a terminal and see what Visual Studio Code is saying about this. And it is going to say an enclosing function local variable cannot be referenced in a Lambda body unless it is
I
in
went
the
to go
capture
grab a
list. And you
doner
see that
kebab.
this is really
That
descriptive.
sounds
Okay,
delicious.
we have seen this error, but we want to see what the compiler says about this. We're going to pass this.
All right, let's see what the compiler says about this. Run task, and it should break. Yeah, it doesn't work, so let's open go to a new terminal. Put debug console terminal. Yeah, let's run it. Let's try running it again. It should. How you liking lambdas? They're very. I'm kind of curious why you would choose to use a lambda variable, a lambda function over any other function, and specifically with when we do it like this, it feels rather not specifically, particularly when we do it like this, because we're just naming it, and we could have done the same thing without without all of this cryptic shit. He used the word cryptic, not me. I've been informed that they're apparently useful and have been and are like there are times when you would want to do that, but I'm without an example. I think I'm a little bit unsure as to why. Yeah, so this is the same error twice in a row here, but it's basically what it's saying is in lambda function A is not captured. Yeah. So if we could fix this by doing like this, I think. Hopefully that would fix it. If I run it now. Yeah, that one works just fine. So we can. But let's see what Mr. Gakwaya says.
Through GCC, and we should get a similar error. It is going to variables that we want to capture. So we're going to say a comma b because that's what we want to capture here. And the moment we do that, Visual Studio Code should be happy. It is not happy. I think
Mostly
we need
run
to
it
compile
inline.
this for it to be happy. So let's do that.
I
And you
assume
see
that
now
means that like
our variables
because
are
you haven't
being
saved it or anything, it's
captured,
just
and
like
we are
custom
summing
code.
them up, and we are printing the result of adding them up here by calling the function through a handle we have set up here. Hopefully this is really making sense. Let's build the program again. So let's use the GCC. You're going to see that the build is good. We can clear and run Rooster. We should see a plus b is 30, but the values are getting inside the Lambda function through our capture list. They are not going through the parameter list here. This is really something you need to be aware of. Now that you know how capture lists work, let's see that you can capture either by value or by reference. And we're going to see what that means exactly. I am going to go down here and put in a piece of code to play with capturing by value. Okay, let's do that. We have a variable called c. The value is 42. And we set up a Lambda function which is going to capture c with this syntax here. And this is the default syntax we saw.
All right, so we're gonna go create our new integer, int c 42 auto func equals, and we're gonna capture. We want our capture list to include c, and then we don't have any specific parameter, and we don't have a specified output type. So std cout inner value. Let's see. So this one should just say 42. Like if you need a max function once and never again, you can just do it with a lambda and save the result to a variable. Yeah, but like I feel like if you have a function for something, unless you like what the oh god, let me brain more gooder right now. The thing that I said was like I was kind of under the impression that functions are kind of like a build your own tool set thing, where it's like, okay, I have X, Y, and Z problems to solve. I can solve them using A, B, and C functions as like tools. You know, I think it would be, I feel like it would be very rare to run across hey, I have to solve this problem one time and never again. And like, I, I guess I'm wrong on that because like I said, I've been told already, but it feels like the kind of thing that just wouldn't be that common. And then, like you said, if you do run into that problem, you just solve it in line instead of creating a function for it. It's very strange to me.
Like we did on top here. So we are going to be capturing like this, and if we do this, we're going to be capturing by value.
Yeah, we're capturing by value here. Then we do our for size t I and I is less than 5. And then we increment I. We create our std cout, outer value. Then we do c, std end line. Then we call our function. And then we increment c. Okay. So this is the function that we saw in the slide that had me a little bit confused. But I think okay, seeing it like this, I think I understand. So we have our auto function is captures our function captures c. And then we have our inner value c. So then here we create a range-based for loop. And inside this range-based for loop, we have our outer value of c, which does 42. So it should just say outer value 42, and then it calls our function, and it says our inner value, so that should also say 42, and then it increments c. But because it's incrementing the c inside of here, this does not actually change. So the inner value and outer value, I think, should both stay 42 the whole time. Using a Lambda to create the player character in a hardcore game you can only play once per save? Jesus. Lambdas are a cool thing you can use, but don't have to use ever. Interesting. I meant you do the Lambda inline? Huh. I mean, it seems very cool. I mean, like, just look at this fucking, like, just look at this text. It looks like, one of the things I said is like, man, imagine receiving instructions that look like this and understanding what the fuck to do with them. That's fucking weird. Still cool. And they look ugly if it takes more than a line or two. Yeah, I mean, then I guess they would, yeah. I wouldn't know because I'm only looking at stuff that's like 1 or 2 lines. But this should print 42 basically, or outer value 42 and inner value 42, a total of 5 times.
Meaning of that is that what we have inside our Lambda function is not going to be the original value here. It is going to be a copy of what we have there. What we can do here is use this thing in a loop and really prove this. So we're going to loop 5 times from 0 all the way to 4, because this is going to go until I is no longer less than 5. And inside we're going to print the outer value, which is going to be the c here. After that, we're going to call our Lambda function, which is going to print the inner value in the Lambda function. And we're going to see that the incrementation we do on the outside, which is going to affect the outer value here, is going to be visible inside the Lambda function here. And that's not going to be the case. The change we do here is not going to be picked up by the Lambda function here, because what we have inside is a copy. So what we're going to see is for the outer value to go from 42, 43, 43, 45, and it is going to go until we hit the end of this loop here. but the inside value is not going to change because the change we do in here is not going to affect the copy that we have in our Lambda function here.
Wait, but does it only take the one value? So if the outside value is changing, if the outer value does change with each iteration, what the fuck is the inner value doing then? Like, I get that it's a copy. That much he's stated, but does it take the copy exactly one time and never recopy it if this one's changing? I've used them before. They're good for when you need to get some averages of different arrays, but only need that calculation in one function. I mean, that makes sense then. That would make sense, I guess, because you're not gonna unless you have that exact array a second or third time. Functions are tools, lambdas are cool sticks you found on a walk. I need to run this. This is fucking bugging me. I need to I need to see I need the answer. So inner value is 42. Outer value is 42. Inner value is 42. Outer value is 43. Inner value is still 42. Okay. So fundamentally, I can understand that this is incrementing this. But I feel like so this one auto function C. It's not taking a new value each time? Huh. What the hell is that?
Hopefully this makes sense. And again, if you
Not
have a
really.
problem, please make sure you ask through the course platform and I will do the best I can to help you out. For now,
I mean, if it is just taking the first value and regurgitating that same value every time, I guess I kind of get that. Because we go through, C is assigned, auto function, we create our thing and it captures C. And then we go to here with our range-based for loop, and first we print outer value. We use our function, which prints out the same value, and then we iterate, and then we go through the loop again. We print our outer value, which is C, which is the outer value is now 43, and then the function is, I guess, just unchanged because we've created the inner value already. I don't know. It feels to me like this when this line comes through again, that when it goes, it would be like, okay, well, we have our new value here. That's very strange. I don't understand that one. I don't understand why that one doesn't increment. I use lambdas almost exclusively to do things with arrays. I mean, if they work, they work.
now we're going to build and run this program. You see the build is good, so let's clear and run rooster. You're going to see outer value is 43, outer value is 43.
That thing I said earlier with lambdas being classes with an overloaded function. Here, C gets copied into the hidden lambda class back when autofunc gets its value. Oh. So that's why it's not like... That's why it doesn't recapture the value here? Is that how my understanding... Is that a correct understanding? It's like it gets the value one time as a result of being a class and not a function? Kinda? Oh god. I don't... So the C in the lambda is technically a different int C. Oh. It's a... I kind of get it, but I kind of don't. Like, I understand that it's different, but I kind of wish I could just see why. I fucking hate this auto shit, dude. Like, God. See, if I mouse over it, it says, like, class lambda, right? But I haven't done anything with classes yet. But we saw before with overloaded functions, you could use something of the same name. You could print and C to see C's address in and outside of lambda. That is a good point. Yeah. I imagine I'd do this. I'd just do what is it? And C. And then I have the same thing out here, I guess. I think that would work. All right, well, it printed the same one on the inside. The main thing is that these two. So there are two different values. It's not C, the same, it's not the same C. But like we understood that from before though, with like when a function is like copying stuff and then like working on it inside and then that doesn't affect the outside. Now we're doing something on the outside that doesn't affect the inside. It's like backwards from what we've seen before, which is super fucking weird to me. I don't know. Maybe that's the use of this thing. Maybe that's like a thing that this does that I just wasn't aware of. It feels so fucking strange. But we can see that they have different addresses. The outside address is this one, the 884, and then the inside one is 880. That's still... I mean, I guess I can understand that this is how it works. I guess understanding exactly why is something I'm not... I don't know. You know, I'm like ruminating on it too much and complaining that I don't understand. Let me maybe Gakwaya Sensei will teach it to me and tell me exactly why it doesn't work this way. I feel like that's what he was getting at, and then I started getting like wrapped around the axle about it. Like, why? Why doesn't it work?
Outer value is 44. Outer value is 45. The outer value is changing, but the inner value is staying at 42, as you see here. Hopefully,
it's kind of difficult to get at first. Moral of the story is that lambdas are weird and should rarely be used.
Are two different things. But we can even go further and print the addresses of the outer value and the inner value. Let's do that. We're going to add that to our
Gakwaya Sensei, is that you?
The address of this guy. So we're going to say address of outer value, or say address of inner value. We can say it like that to really be descriptive in our terminal here. So we're going to say the address of C, and on the outer value, we're going to add another piece of information and say address of outer value, and we're going to say the address of C. And this is going to pick up the outer value that we have here, and this is going to use the inner value we have in our lambda function here. Let's try and build, and hopefully these two addresses, the inner and outer addresses, are going to be different. That's what we want to see here, and really proving that what we have inside the lambda function is a copy through the capture mechanism. So let's run the program. The build was good. So the outer value, the address is DE4. The inner value, the address is DE0. We are proving that what we have inside our Lambda function is really a copy. So this is how you can capture by value, and that's going to make a copy. But sometimes you really want to capture by reference, and we're going to see how you can do that.
Oh boy.
So we're going to comment out the code to capture by value here. We're going to grab the code and reuse it because that's going to be very similar to what we had before. We're going to say capture by reference. We're going to
I'm going to put this in here real quick. There. I'm just going to put this in here. Might as well do. Was one too many. There. Okay. That way we can keep this the same. Boom. Boom. This is what I get for, alright, capture by reference. And this is the... How much of this did he copy?
very similar to what we have. Grab the code and reuse it.
Alright, it looks like he grabbed literally everything. Got it. I can unfuck it at my earliest convenience.
Because that's going to be very similar to what we had before. We're going to say capture by reference. We're going to put in our code and we're going to change it a tiny bit. What we're going to do is add an ampersand symbol in front of our variable here that we are capturing. And we're going to say ampersand. The moment we do this, what we have inside
passing
the
by
function
reference.
is no longer a copy. It's going to be a true reference to the outer value here.
Yeah.
And now the changes
we've covered before.
Our outer value are going to be visible inside the Lambda function here, and you're going to see the addresses to be the same. Let's build and really see this. We're going to use GCC to build our program. The build is good. We can clear now and run Rooster, and we're going to see that the outer value, let's make sure we have some spaces after these guys, and let's go up and do that and build again because things are really cramped together and I don't like this. So the build is good. We can clear and run Rooster. So we're going to see the outer value and the inner value are changing together, and the addresses are now the same because we have captured by reference. The inner value and the outer value are referencing the same variable we have outside here.
Yeah, we can do the same thing with pointer, right?
In this lecture, I hope you found it interesting. The main idea was the capture mechanism we have with our Lambda functions to capture things outside the context of Lambda functions. We can capture by specifying a comma-separated list of the variables that we want to capture, and we have the option to either capture by value by using the variable directly in the capture list like we do here, or by prepending an ampersand symbol here and capture by reference. And you are going to have to choose whichever way you want to capture your variables now that you know about all these options here. We are going to stop here in this lecture. In the next one, we're going to see how we can capture everything from the outside context to the Lambda function.
Oh boy.
Go ahead and finish up here and meet me there. In the last lecture...
Alright, give me 1 second. I'm going to go ahead and comment out all of this stuff, but we're going to keep using this same file. But I do kind of need to take a quick bathroom break. I think I'm going to give it like 5-10 minutes, and then I'll be right back. It'll be fucking whatever. I'll play some elevator music or something. Where is it? Yeah. All right. I'll be right back, guys. Fucking. All right, we're back. Oh, sorry about that. Oh, okay. So that was Lambda. Well, I mean, that's halfway through Lambda functions, I think. Let me see. Oh, we're closer to the end than I thought. Okay, that's good though. That's good. So capture all in context. We only got like 5 minutes left in the. I almost said mission. 5 minutes left in the lesson. But you know, it takes me fucking forever to understand anything. So it could very well be another 15 minutes for me. Let's go.
We saw that we could capture things outside the context of the Lambda function.
Right.
Now we want to see that we can capture everything living outside the context of the Lambda function. The syntax to do that is ridiculously simple.
Good.
If you want to capture everything by value, you just put an equal sign in your Lambda function.
I like how he sneaks that in by value.
If you do something like
or not
this,
sneaks, but you know.
now you're going to have access to everything outside the scope of the Lambda function. For example, we can access the C variable here from the Lambda function, but if we have any more variables declared outside the scope of the Lambda function, we will have access to them inside our Lambda function here. Again, this is enabled by the syntax that we use here by putting an equal sign inside our Lambda function. Notice that if you use the equal sign like we do here, we're going to be capturing by value. What we have inside the Lambda function is going to be a copy. If you don't want to capture all by value, you can capture all by reference. And again, the syntax is really simple. All you have to do is put an ampersand symbol.
So he hasn't covered capture by pointer. Is that because you can't do that?
The context of your Lambda function, but that's going to be by reference. What you have inside the Lambda function are going to be true references to the outside variables, and you can do pretty nasty things with them because the changes you do inside the Lambda function are going to be visible outside the Lambda function, and any change you do from the outside is also going to be visible inside the Lambda function. So if you do this, make sure this is what you want, and you can use this to your advantage. Okay, now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay,
yes,
here we are
please.
In our working folder. The current project is Capture All Lists.
So capturing by reference is enough.
Our template
I imagine it is enough, but I was mostly curious whether it was possible.
Let's do that.
Because it seems like there's a lot of different ways to do different things. If it's not possible, then oh well. I'm not going to be heartbroken about it.
And we're going to close the left pane here. The first thing we want to do is to capture everything by value. And we're going to put in the code to do that, which should be very easy to understand by now. And again, the syntax to capture everything by value is by putting an equal sign within your capture list. You have to put that within these angle brackets, and that's going to capture everything by value now. Now, if we run the program, we're going to see that C has been captured by value. If we loop around, we're going to see that the outer value is going to change. But
not possible as far as I know. Okay. I mean, the redundancy of pointer and reference, I imagine, renders it kind of pointless to work in both. It's not like because both essentially, the idea is that you're editing something directly at the address, right? That is why the syntax looks the way that it does, because it's just it is using the address, right? So it's not like doing it by pointer as well is it's redundant, but it's also but it's also unnecessary, at least in this context, I'd imagine. I can't imagine. But I also don't know why you would choose to do something as a reference rather than a pointer in other contexts as well. I mean, like the idea seems like if you just kind of do whichever one you prefer. Unless there's like, I mean, I've learned so many things. I don't know how much of it I might have forgotten, which is probably a not insignificant amount. Okay, so he doesn't have the address for the C's anymore. So we'll do this. So we have our C. Yeah, not sure why they left it out in this one specific case. Oh. I'm making observations. You know, sometimes when I'm doing these courses, it makes me feel, or these courses, when I'm doing this course specifically, it makes me feel really fucking smart, and other times I'm like, wow, that's, now I feel really dumb. Today has generally been a smart day. Maybe tomorrow will be a dumb day. So autofunc. So here, we have the syntax for I keep calling it syntax. We have the thing for capturing everything. So if I create like a fucking, I don't know, 12 more things, they'll all get captured in this function.
But the inner value is going to stay the same. This
Right,
is the same
because we're
behavior
passing
we
by
have seen
value.
before by capturing by value. So let's build again. We're going to build with
You can save pointers
GCC.
to a
The
shared
build is
PTR
good.
or
We can
unique
clear
PTR, which is
and
useful
bring up a
for memory
terminal so that
management.
we can clear properly. So let's do clear and run rooster. Now we see that the outer value is changing, but the inner value is not changing. And again, this is classic capturing by value. If you want to capture all by reference, you're going to use the ampersand symbol here. And let's do that. We're going to comment this out, and we're going to take this out and use the code here. We can do that. We're going to go down and put in a code and say that we are capturing by reference. We should say capturing all by reference. And all we have to do to make that work by reference is to put our ampersand symbol within this angle brackets here. And this is going to capture everything by reference. If we run now, we're going to see that the changes we do from the outside are going to be visible from the inside here. Let's build with GCC and see that this is actually the case. The build is good, as you see here. We can clear.
Yep, and then it's 42, 42, 43, 43, 44, 44, 45, 45, 46, 46. Perfect.
The outer value is changing and the inner value is changing, as you see in our output here. And this is really how you can capture by reference. Just to play with this, we're going to set up another variable, call it d, and we're going to say it contains a 5, and we can try to print that inside our inner value here, and it is going to work. You're going to see that it has been captured. We can say stdc out inner value. Let's say that it is the d variable we are trying to access here, and we're going to say d, and it is going to be visible inside our lambda function here because it was captured by reference here. Let's build again. We're going to use GCC.
I see. I jumped ahead and I was just going to copy the, I was just going to change the value that we had. He's creating a new one. So we'll do the same as him. Inner value C, inner value D. I don't know if it matters that with the outer value. Oh, also, this probably needs incrementing. Actually, we probably should do both, right? Do like that. Then we increment both.
Easy to do that. The build is good, we can clear, and if we run Rooster, we should see D printed out multiple times. D, D, D,
Yep,
D.
it's all
and
getting
we are
incremented.
able to access it through the capture mechanism, and we are capturing everything in the context by reference here. This is really all we set out to do in this lecture. I hope you found.
I kind of want to see what this looks like if I just capture it by value. Terminal, run task, G++. And we run, so we have here, and it's just doing inner value 42, 5, 42, 5, 42, 5. And then our outer value, our D is getting incremented. She increments my D. You know what I'm saying, guys? You know... No? Oh, okay.
found it interesting. I hate to say it, but this happens to be the last lecture in this chapter on Lambda functions. We still have a lot to learn about Lambda functions, but unfortunately, we don't really have enough tools to understand that now. But for now, we're going to stop here and learn a little more things about C++. Then we're going to come back and see some crazy things you can really do
I'm
with Lambda functions.
setting up some
I would
expectations
like
for the
to
future.
welcome you in this new
Okay, so function templates I think is chapter 15. Yep, that's chapter 15. Wow. Holy shit, guys. We did it. So that's chapter 14 complete. We've only got 5 chapters remaining. Now, granted, they only get longer from here. Wow, doing templates already. I know, right? What's a template? This is going to be good to watch. Oh boy. Well, that will have to wait until tomorrow. Because we just finished a whole chapter today. But yeah, we can look forward to that. It'll be fun to do, probably. Here, let me save this. We'll close it real quick, and then I'll open my thing. So we're on chapter 15, function templates, and this is at 17 hours, 40 minutes, and 8 seconds. Look at that. It's a template that the compiler copies. I like templates a lot, but at the same time, I hate them a lot. Oh boy. You make a template and it makes as many versions as there are uses. Interesting. That sounds like something that could be incredibly useful if you can master it. But it also sounds like the kind of thing that'll be really confusing if I don't pay attention. So anyway, anyways, guys, that's a pretty good thing. I think we'll call that you remember your 3 max functions. I'm going to assume that it makes it so that the compiler can. Yeah. You make one template instead of those 3. Interesting. I imagine that this works for any sort of like other thing. Are you completely new to learning programming or just C++? Completely new to programming. I have like very, very little. I have like limited experience with things from like high school, 10 plus years ago. I did like a little bit of Unreal 5 2.5, maybe 3 years ago now. But that was like, it was helpful, but it also, I had too many questions that weren't being answered, and then I didn't stick with it like I should have. I mainly use them for vectors, matrices classes. Oh boy. I mean, I guess I'll see how how they're used tomorrow. It'll be interesting to see for sure. I'm looking forward to it. So anyways, guys, I'm gonna hop off. It's been a good time learning Lambda functions. I have far from mastered these things, but here's hoping that here's hoping I can keep up. No way, man. I'll check your channel. I'm new too. You might be inspirational. We'll see. We'll see. I've only been doing this for like 2.5, maybe upwards of 3 weeks now. so hopefully it's. I mean, if it's inspirational, then you're welcome. Yeah. Let me just huff my own farts real quick. But yeah, so we're gonna come back to this same time tomorrow, 3 p.m. U.S. East, whatever the fuck, daylight, say, or standard. I can never keep track of which it is. And then I'm gonna try to be live tonight. There's a chance that I won't be. I might have to cancel Resident Evil 2 tonight. But I have a video that should be going live here in like 9 minutes, just about my experience playing Bardsdale. So check that out if you're interested. With that, I'm gonna get out of your guys' hair. I hope you guys had a good time hanging out with me. I've had a good time hanging out with you. We'll be back tomorrow, same rag time, same rag channel, and fucking learning about function templates and seeing how best to how those are used. Later, guys. Bye.